give it up for Jorge.
Thank you. So, Sander said, Jorge, I work for ServerDensity. I do quite a few things there. These are my Twitter account, our ServerDensity Twitter account, and our DevOps blog. That's probably worth reading, even if this talk is boring for you. You can entertain yourself. But today, I'm going to talk not about our product, ServerDensity. By the way, we are monitoring, server monitoring and website monitoring solution. So if you need monitoring, check it out. I'm going to talk about how we run our infrastructure and what we have learned doing it. And one of the things we have learned is to train our ops team, and we basically train them by, like if they were pilots. Probably all of you here today, you know what it's DevOps. I'm not going to repeat myself. You know it already. But yes, I would like to highlight that on DevOps, or the DevOps movement, has focused more on the tools that rather applying those philosophies to people. We see how infrastructure is being automated, configuration, obviously. Then we have continuous testing, continuous delivery, monitoring us. You handle logs, you handle even feedback. So there is this whole philosophy of human ops that about DevOps that has been applied to all the different tools. But humans, who are the people who design, who build infrastructure, we are not handling them in a different way. And we gave this the name of human ops because it's applying DevOps to humans. And that's what I'm going to introduce to you today, and we'll see how it goes. Humans are part of any system. We do the initial design, so we build the systems. We maintain them when they break. We upgrade them when we find security issues. And every time there is an issue, an incident, we need to be on time and fix them. But as part of being humans, we make mistakes. We sleep, we lapse, we even on purpose, we do security violations and we break things or we give secrets to other people. By the way, next talk is about secrets and how to handle them. And how you can handle that factor, that human risk that you have when your infrastructure is run by people. We have seen that all the health of your infrastructure affects people, affects the humans running it. If you are on call and you are getting pagers all the time while you are sleeping, probably the next day you won't be able to work as you should. If you wake up in the middle of the night and you have an incident that you need to fix, how your human side, your feelings, how is that going to affect? And then, because you need to fix it, your health is important to the health of your system. So that has a bi-directional impact. Downtime is loss of reputation, users, revenue, and basically we have seen that unhealthy teams have a direct impact on your systems. What we can do and how we can measure this impact, because you might think, well, this is a good idea. It's probably a nice to have because I have other priorities, and, well, we can leave this for the future. Well, we'll see that this has a real impact. It's considerable, and what we need to do is to be prepared for downtime, for incidents, for issues, prepare, practice, and then learn how to respond to them. This is the key. And I'm going to show the importance of handling this human side of things when running infrastructure with very small example. Us in ServerDensity, we monitor quite a few hundreds of thousands servers. And as you can imagine, we have a big infrastructure to hold all that monitoring. A few months ago, our hosting provider had an incident in one of the data centers, and they lost power. And their first backup generator went down. The second backup generator didn't work. So in 1 second, half of our infrastructure went down. We were prepared for that situation. We knew that we had to do a manual failover. By then we didn't automate that procedure. Now it's completely automated, but by then it was a manual process, and we had to switch our DNS. We have our playbooks or run books to run all the procedures. I'll show you this later. And we knew this procedure was taking 20 minutes. Once we finish the incident and we get things back running, turn out that it took us 43 minutes. So there is 23 minutes difference between theory and reality. And if we had everything ready, we would fail. Where did those 23 minutes go to? Well, that was a human factor. If you want to read the full story, all this is public, so you can go to our status IO page and read. Lessons learned, the human factor. After this, when we were writing the postmortem, we saw that there were a few things that were the consequences of those extra 23 minutes. Unfamiliarity with the process. The engineer on call knew how to do this procedure, but he had never done it. Like, you don't switch DNS every week. That's probably one of the things that you do once. You practice in theory, and that's it. Well, then he had the pressure of a time-sensitive event. When the whole infrastructure of your company goes down, you feel a little bit of pressure, even panic. So we had to handle that thing. And because he was feeling pressure, he didn't know how to properly react. He had to escalate this. So we see unfamiliarity, pressure, stress, panic, escalation. How we can fix or how we can handle. Well, we had this previously, but this is a process that we have highly improved afterwards. Every incident that there is in your infrastructure should follow an established procedure, what we call the general response process. Our process, it's more or less like this. First, as soon as we get an alert, a notification, we use PagerDuty. You could be using something else. We acknowledge the alert. So we recognize that there is a problem, and we are going to start having a look at it. But beginning the investigation, you see, is the last step. Our general procedure is, first of all, load your checklist. I'll be speaking more about checklist in the next minutes. But we have a checklist with everything an on-call engineer needs to follow. That way, he will never jump or forget any step. The second step for us is to go into our chat room. We use a Slack, but you could be using anything else. And we have a specific room just for incidents. That way, when you need to escalate this to someone, when your colleagues, they are offering you help, all the conversation takes in a single place and you are not disturbed by other things. And then we open a Jira. We are using Jira for issue and tickets because our development team, they are using them, but then our operations as well. That way, anyone who's joining the investigation at any point, he knows where we are, what has been executed, what has been done so far. And it's very useful when you finish, when you fix the incident and you want to write a postmortem. Logging everything into issues is very, very convenient. Then our final step of the general response process is to start working on debugging or troubleshooting the issue. It's very important to follow all these steps to help work together in a team. How our documented procedures look like? Well, we do a very extended use of checklists. Why checklists? Well, checklists, they are used everywhere. Why? We deal with very complex systems, and we cannot see the whole picture or have the whole picture all the time in our brain. Some people, they say that they are super good sysadmins, super good DevOps. They have built this thing, and because of that, they will be able to fix everything always, no documentations, they are super hackers. Well, complexity, stress, fatigue, you wake up in the middle of the night and then what the hell, maybe you are half asleep, you need to fix things, having a checklist, it's very useful. And this is not something specific for operation guys, pilots, doctors, even divers. I do diving, and one of the first things they teach you on the diving training is Bruce Willis runs all films. That's basically checking your BCD, your weights, releases, air, and everything else. When you go inside of the water, if your equipment fails, probably you will be dying. So if your infrastructure fails, you might not die, you might get fired, or you might have the pressure of fixing all that. So having a checklist that helps you run through all the steps is a very good idea. But checklists, they shouldn't be followed blindly. We have seen this, this is the checklist, I'm going to do whatever is here. Well, we are humans, and we should take advantage of that. We are not machines. So think twice, what are you running? Other things that they are very interested about your checklist or your run books or playbooks is to keep them in a very independent system. If your infrastructure goes down and your documentation was there, you won't have anything to do. So, for example, as we keep them in Google Docs, it's there, it works most of the time. It's nice that you can search because these documentations tend to increase and increase, so finding the right doc, it's very interesting and useful. And then keep a list of known issues. Most of the things that will be happening in your infrastructure is something that has happened before and someone has fixed it. So if you document how to fix it, or you know some of your limitations, you will be making the lives much easier to the people on call. But not only checklist is the only thing we do, and it's actually the title of this talk, War Games. What are war games? Are we shooting at each other? No. What we do is to run simulations of all the incidents. We saw that unfamiliarity with the process was one of the consequences or the causes of those extra 23 minutes. So now we play all the different, or we train all the different procedures, or we basically, what we do is to create a parallel environment. Nowadays, thanks to cloud infrastructure, it's very easy to spin a very similar environment that you have for for production into a replica for testing. And you can run commands. You can have half of your team breaking things and the other half of your team fixing them. And they don't know what has been broken. You randomly break stuff. And one of the things it's very important is to break many things at the same time. On real incidents, they never are caused by a single cause. So when you break quite a few things at the same time and you throw completely unexpected results to your team, it's basically the best training you can do. Let me check how I'm going with time. That's perfect. Well, the results of all this training, we run this training every 2 weeks. It should be run as often as possible. Obviously, your operation teams has other tasks, but your infrastructure is going to be changing, so it's good to do this often. We have seen that our team, the whole operation teams, and then individuals, engineers who are on call, they testing all these things, they feel better with themselves. They train people, they run real commands, you train the procedures, so you keep improving them, and actually you also train your tools. You improve your tools to reduce all the time required to fix the different incidents that you might have. As I said, people increase confidence when you have fixed something before and you have your infrastructure down and you know how to do it. When you did it yesterday, okay, well, this is not training. Now this is the real thing that needs to be fixed, but they feel very confident. You reduce the panic effect Okay, the infrastructure is down, but I'm confident with myself. I'm going to fix it. You also increase or you improve the coordination between your people. When complex incidents happen, they are usually not fixed by a single person. They get escalated. You have a couple of people doing troubleshooting, debugging. You increase when you train that troubleshooting between people together in a team, you improve. And another consequence of that is that you improve trust in your colleagues. If there is someone new in the team, you might, and you need to count on him on doing one side of the troubleshooting, you might not feel very comfortable. So doing those exercises help to increase trust on your colleagues. At the end, what we see is that those 23 minutes can be reduced to 0. This needs to be done as often as possible. Your infrastructure is going to keep changing as you release new features, as you optimize. So this is a leap. We do it every 2 weeks, but it's depending on your team and how fast you move. It's a good recommendation. And well, what other things you can do to improve the efficiency on how you run your infrastructure? Well, on-call rotation design, not to get the same people fixing the same things all the time. Alert priorities, don't push, don't send tests or messages to people on call all the time. Just trigger the things that they are actionable, that they need a human to do something, otherwise automate that, and send as less or as few notifications as possible. All this philosophy, all these ideas on how to improve the human side of running operations, we have put them together in something that we have called Human Ops. And we set 4 principles that should be able to define this. Humans are part of the systems. Humans impact systems as they need to fix them. Humans impact business. If your infrastructure goes down, that has an impact on your business. So this is a topic important enough to consider it when you are running a system. And at the end of the day, human issues count as system issues. To get more people talking about human ops, how they are doing this in their organizations, we have created a meetup that you can check it out. First one will be in London next month, and we'll be having some talks and people sharing experiences on how they run their teams at a scale. And well, one of the things we created to help people using cloud infrastructure is this free app that has nothing to do with our product. So if you're using infrastructure in one of these providers that we support, you can get notifications when there are incidents in your cloud provider. Well, that was it. If you have any other question or you want to share any experience. Who's doing, yeah. This is completely up.
Sorry, what was the question?
Yeah.
I was asking about the frequency. Doing this every 2 weeks seems a bit intense to me.
We do it every 2 weeks, but it's completely up to you. It depends on how fast your infrastructure is evolving. If you're making a lot of changes, maybe it's convenient to do it that often. If your infrastructure is stable and you are not introducing changes, you can do it every 2 months or once a month. There is another question over there.
You talked about testing unexpected failure modes,
Mm-hmm.
and how do you find these? So you can test a database fails or
Yes.
a partition,
Yeah.
but how do you find a list of everything to test?
It's up to the sysadmins to decide what kind of things they break. What we do is to have half of the team or part of the team randomly breaking things. They decide what it breaks and how they do different combinations of all these things being breaking, and then the other half of the team needs to figure out.
Yeah, one more.
Actually, it's not really a question, but just thinking about it and the fact you're trying to set up a meetup, you could make it kind of gamification for that, actually, by having half of the team, which is like defenders and attackers. And I mean, I don't know, it could be one fancy way to motivate people and have at the end of the month or the year, I don't know, ranking.
Yeah, that's a good idea.
Yeah, I really like that suggestion. Actually, Alex was just talking about that, right? Yeah.
Okay, I have a question related to the reluctance to use checklists. What if the team members don't claim they don't need any checklists? In other words, how do you fight the ego?
Would you be flying on a plane with a pilot who is not using checklist? I mean, it's not a decision of them, of the different engineers. That's the procedure, and they need to follow. It's part of that's part of the procedures for handling ego. If they don't need it, that's not true.
All right. Any more questions? Yep, in the front.
Would it not be better to just remove people from the system and have the system fix itself?
Yes, actually, every time that we can build self-healing system and automated response is the best thing to do. Machines, they don't fail, or they don't tend to fail. Humans, we tend to fail. So that's one of the things you should do. Obviously, that's an ideal situation, and until now, we don't have systems that they are building themselves. So maybe in the future, that's the way to go.
Okay, well, thank you, Jorge.
Thank you.
Applaus.